Hi, everybody. We're going to look at surface area again today, but we're going to do the surface area of triangular prisms. And triangular prisms are basically made up of two triangles and three rectangles. So these three-dimensional shapes have 5 sides. You can think of a triangular prism like a tent, or if you've ever had a Toblerone candy bar, that's the shape that we're looking at. Okay, so anytime we're dealing with a prism, it means it has rectangular sides. And so the fact that it's a triangular prism means that it just has triangle bases, but rectangular sides. Okay, so there's actually 3 kinds of triangular prisms, and it depends on what kind of triangle your bases are. So there could be an equilateral triangular prism, which means your triangle has all equal sides. You could have an isosceles triangular prism, which means that 2 of the sides of your triangle are the same. And you can have a scalene triangular prism, which means none of the sides of the triangles are the same. So we'll talk about that. We'll go through each of those examples so you can see how that changes the surface area depending on what kind of triangle we have. Okay, so just like we did with rectangular prisms, we are going to be finding the area of each of the sides, and at the end, we'll add all of those together. Okay, so the only thing that's different is that with a rectangular prism, we had 6 sides, and with a triangular prism, we're going to have 5 sides. Okay, so 2 triangles and 3 parallelograms. So in the first example, you guys should see that we have a triangular prism here that has an equilateral triangle for its base. And so what that means is that all of the sides of your triangle are 6 inches. So we can label that. And the way I could tell that it was an equilateral triangle is because it had these marks here. Remember, those are called tick marks, and it shows you that all of the sides are the same. Okay, so the way that we're going to do this is we're going to start by finding the area of the 2 triangles. Now, what's kind of nice is that every time your area of your 2 triangles will be the same. So all we have to do is find the area of one, and then we can put it in our list twice. So let's start by writing down the formula for the area of a triangle. And so looking at this triangle, I need to figure out what the base and the height are. So remember, to find the base and height, you kind of look for where the right angle is, and the 2 parts that make that right angle are your base and height. So in this case, my base is 6, and my height is 5. So the area of this triangle, 1/2 times 6 times 5, is 15. Okay, so what I'm going to do is over on the side here, I'm going to actually start a list of the areas of my sides. So now that I found that one of the triangles has an area of 15, I'm going to list that there. And like I mentioned, this triangle that's in the back here, this one back here, is the same area as the one we just found. So I'm actually going to list that out twice. So those 2 sides have the same area. Okay, so the last thing we have to do is we have to find the area of each of the rectangles. So the rectangles I'm talking about here are this one. Okay, so we can start with that one. So kind of like if you think of this like a tent, it's kind of like the right side of your tent. So that's what I'm going to start with. So area is length times width for a rectangle. And so I'm going to have, it looks like a length of 17 and a width of 6. So the area of that rectangle is 102 inches squared. So I'm going to put that in my list here. Okay, now the next side we need to do is kind of the left side of our tent, I'll call it. So that's this back side here. Can you guys see that? Okay, so that rectangle has a length and width of 17 by 6. So it has the same exact area as the right side. So I'm going to put another 102 there. Now the last side that we have to find the area of is kind of the bottom. Okay, so this kind of the bottom of our tent here, we'll call it. So this piece down here. Okay, so to find the area of that, I can see the width is 6. And if I know this side is 17, that means this side is also 17. So again, that rectangle is 17 by 6, which we've already figured out is 102. Now, that won't always happen where all of your rectangles have the same area. The reason why that happened for this one is because I had an equilateral triangle, which meant all of the sides of my triangle were the same. And when that happens, that makes the width of all of your rectangles the same. Okay, so it's really nice when you have an equilateral triangle because you're only you're going to use that side for all of your rectangles. Okay, and we'll see what happens in a minute when that's not the case. Okay, so double check, do we have 5 sides? Yes, so if we add up those 5 areas, we're going to get that the surface area is 336. So my answer here, surface area equals 336, and remember it's inches squared because technically it's still area. Okay, so let's try another one. So here's another triangular prism. You can see it has 2 triangles as its base, and then there's 3 rectangles around the sides. So let's start with the triangle. So formula for a triangle is 1/2 base times height. So I need to pick out what is the base and what is the height. So again, look for the right angle. The 2 sides that make the right angle are your base and height. So there's the 2 sides that make the right angle. So we're going to use 5 and 13 for our base and height. Okay, so that 12 you see there, that does not matter in terms of the area of the triangle because it's not making up the base, or it's not making up the right angle. Okay, so 5 times 13 is 65. 65 times 1/2, or divided by 2, is 32.5. All right, so I'm going to start a list over here again. So 32.5 is one triangle, but remember, this other triangle down here has the same area as this triangle up here. So I can go ahead and I can just double that. Okay? All right, so now I'm ready to deal with my rectangles. So I am going to erase this, and let's start. We need a length times width. Why don't we start with this side over here? You guys see this rectangle? I'm going to shade it so it's easier to see. So that rectangle has a length and width of 15 and 5. So 15 times 5 is going to be 75. So I'm going to add a 75 in my list. Okay, so now I'm ready to do another rectangle. I'm going to choose to do this side here. Okay, so I can see the length of that rectangle is 13, but I don't know the width of it. But since I know this is 15, it must mean that this is also, because opposite sides are equal. Okay, so I'm going to be doing for my next rectangle 13 by 15. Okay, so the area of that one is 195. So I'll put 195 in my list. And so we're only missing one more rectangle. And that one, let me get rid of all this, is this one that's kind of messes with your eyes a little bit. This one that's kind of in front. And we can see that that's a 12 by 15. So 12 times 15, which is 180. Okay, so let's double check. We have our 5 sides, so we can go ahead and add. And we are going to get 515. So the surface area of this triangular prism is 515 square yards. Okay, so one thing I want to point out with that one that we just did is that because this was a scalene triangle, meaning all the sides were different, all of our rectangles were different. Okay, so in number one, because all of the sides of the triangle were the same, all of our rectangles were the same, but in this one, all the sides were different, so all the rectangles were different. So kind of something good to point out so that you can make sure that you're using the right numbers. And so one thing that I usually say to kids, and this might help, is if you look at the sides of your triangle, so 13, 12, and 5, your rectangles, your 3 rectangles, those are the widths of them. So we had one rectangle that was 5 by 15. We had one that was 12 by 15 and one that was 13 by 15. So that's kind of a nice way to, if you have a hard time visualizing the sides, you can never go wrong if you can just do each side of the triangle times the height of your rectangle there. You'll always get the right areas. Okay, so that's another way to look at it. Okay, so let's do one more like that, where this one, if you look, it's an isosceles triangle, meaning 2 of the sides are the same. So what does that mean for us? It means that 2 of our rectangles will be the same. Okay, but let's start with the triangles. So 1/2 base times height. So looking at our triangle, again, the base and the height come into where the right angle is. So there's our base and height, since that's where the right angle is. So 1/2 times 5 times 4. 5 times 4 is 20, and half of 20 is 10. Okay, so over my list here, I'm actually going to add 10 twice, because remember, we know that both triangles have the same area. So no need to write all that out again. We can just write it twice in our list. Okay, so the next thing is our rectangles. So let's first talk about the side that we can really see here, this one. Okay, so the length and width of that rectangle is 8 by 6. So the area of that rectangle is 48. So I'll put that in my list. Now, this is tricky because this side over here that we can't see, so I can't really shade it for you, is the same as the rectangle's area that we just found. Because I know that these 2 sides of the triangle are the same, it means that this, we knew this was 6, right, because opposite sides are the same. It means that this is also 6. So the area of this rectangle on the side that we can't see is also 6 by 8. Okay, so we don't have to show that again. We've already kind of figured that out. But the one that we don't know is the one that this is showing back here. Again, that we can't really see, but there's that rectangle on the back. And so to figure that out, I'm going to know, okay, well, the width of that rectangle has to be 5, right? That's this side here. And the length of it, right here, would be 8, because opposite sides are the same. So the area of that rectangle that we can't really see in the back is 8 by 5, or 40. Okay, so I forgot to put my 48 from the last one. Remember, we're doing that one twice because the 2 sides that are the same, and then the 40 is the one that I just found. Okay, so I have 5 sides. I know that I'm good. If I add them up, I get 156. So 156 inches squared is my surface area. Okay, so those are the 3 kinds of triangular prisms that you will see. So what I'd like to do now is have you guys try number 4 on your own. So you can pause the video, give it a try, and then press play again when you have an answer, and we'll compare and see how you did. Okay, so for this one, hopefully you noticed that this was an isosceles triangle for the bases, which means that two of your rectangles are going to have the same area. So let's start though with the triangle. So the triangle has a base of 8 and a height of 5, because those are the two sides that make that right angle right there. So 1/2 times 8 times 5. So 8 times 5 is 40. Half of 40 is 20. Okay, so let's start my list over here. So two triangles, both which have an area of 20. And that's the first thing in my list. Now, I am going to choose to do this rectangle next. Okay, so what do I know about it? Well, not a whole lot right now. Maybe I should have chosen to do the right one first, because the right and the left are the same, right? So I'm actually going to shade this one too. So if I look at that right one, I can see that it's 9 by 7. So I'm going to do length times width, 9 times 7, which is 63. I'll put that in my list. And let me show you why the other one is also 63. So if I know that this side is 9, it means that this is also 9, and it means that this is also 9. So I can kind of treat the 7 the same way. If this is 7, I know this is 7. And because this is an isosceles triangle, I know that that's also 7. So that's why that rectangle on the left is also 63. So I'm going to put another 63 in my list. So the one that we're missing is this one that we can't really see in the back. So like kind of this back side here. So I can see that the width of that rectangle in the back is 8. And if I look here, the length of that rectangle in the back is 9. So the area of that one, 8 times 9, would be 72. All right, so if I add all 5 of those sides together, I hope that you guys got this, 238 meters squared. All right. Okay, so let's take a look at 2 different word problems, and then we will be done with our triangular prisms. So number 5 says, Toys R Us has just come out with a new Transformer line of toys. Each Transformer is packaged in a triangular prism box. The triangle is isosceles, that's important, with a base of 10 inches, sides of 9 inches, and a height of 8 inches. The length of the box is 15 inches. How much packaging paper must be used to cover the entire box? Okay, so if we weren't working through surface area notes right now, you would have to realize that when it says cover, we're talking area. And since this is a triangular prism, meaning it's three-dimensional, they're talking about surface area and not just regular area. Okay, so a couple things to think about there. So what I would recommend is I would recommend drawing a picture of this box. Okay, so I'm going to draw my triangular prism here. I'm going to just kind of go like this. Okay, and they tell me that it's an isosceles triangle for the base. So what does that mean? It means that 2 of the sides of my triangle are the same. So I'm just going to say this side and this side are the same. Okay. So it's an isosceles triangle with a base of 10 inches, sides of 9 inches, and a height of 8. Okay, so base of 10 inches means that side's 10. Sides of 9 mean that the 2 equal sides are 9. And a height of 8 means right there is 8 inches. Okay, what else? The length of the box is 15 inches. So length of the box, 15 inches. Okay, so we have everything we need to figure out how much packaging paper we need. So let's start with the area of the triangles. 1/2 base times height. All right, so the base and the height, remember, are the two sides that make up that right angle, so 10 and 8. 10 is the base, 8 is the height. 1/2 times 10 times 8 is going to give me 40. So if I start my list over here, I now know that both triangles have an area of 40. Okay, so now let's go ahead and find the area of the rectangles. So the two sides that I can see here, I'll call it kind of like the right and left, are going to have the same area because they are both going to be 9 by 15. Okay, they're the two sides of the triangle that are the same, which means that the areas of the rectangles are the same. So I have a 9 by 15, which is going to give me 135. And like I said, there's two of those. Okay, so the last side, kind of the side I can't see, is in the back. So this side back here, I'm going to look at as a length and width of 10 by 15. Okay, so that's that back side. So 150 needs to be added into my list, and that gives me 5 sides. And so when I add all those up, I am going to get 500. So I would need 500 square inches of packaging paper to cover that box. All right, last question here, Toblerone. So I have one of these in my classroom. Such good chocolate. So oftentimes marketers package and label products in a variety of ways to encourage potential buyers to purchase the product. Package design has been an important and constantly evolving phenomenon for years. Toblerone chocolate has a distinctive packaging for their product. The chocolate is packaged in a triangular prism container shown below. The size varies depending on the quantity of chocolate, but the triangles are always equilateral. Find the amount of cardboard used to package this size candy bar. Okay, so yeah, I've seen very large Toblerone boxes, and I've seen small ones. So it's funny though, that's the first thing I think of when I see this three-dimensional shape is the Toblerone chocolate because it's such a unique package. Okay, so what's important here is that they're telling us the triangles are always equilateral. So right away I'm going to draw on my diagram here that I know these three sides are the same size. All right, so let's start with those triangles. Area equals 1/2 base times height. So the base of your triangle is going to be 3, and the height right here is going to be 2. So 1/2 times 3 times 2, so 1/2 of 6 is 3. So I can go ahead and in my list, I'm going to have 2 triangles, both with an area of 3. Now, what's awesome about this is that because it's an equilateral triangle, all 3 of my rectangles are also the same area. So I just need to figure out one of them, and I'll know them all. So why don't we look at the side we can see here. I know this is 3 inches because, again, all the sides of the triangle are the same. And so the length and width of that rectangle is 3 by 10, which is 30. And I know all 3 rectangles are going to have that same area because all 3 rectangles are the same size. Okay, so if I add that up, I'm going to get 96. So the surface area is 96 square inches.